Greetings, everyone. I'm Jeremy Simon with 3D Universe. Welcome to another episode of 3D Universe Untethered. So in this episode, we'll be talking about the MakerBot method and Method X. And we have tonight with us Johan-Till Broer from MakerBot, who will be talking with us. Thank you for joining us, Johan.
Thank you for having me. I'm looking forward to it.
And as usual, we have our co-host, Jen Owen, Creative Director of 3D Universe, here with us. Welcome, Jen.
Hi.
So before we get started, a couple of notes. Some of you have seen the series before and kind of know how this works, but we've got an ongoing series here where we sit down and speak with folks in the industry and talk to them about various aspects of 3D printing and digital fabrication. And these sessions are recorded. They will go online as both a video as well as an audio podcast. You can visit our blog anytime at 3duniverse.org and click on the 3D Universe Untethered graphic in the upper left to get a list of recordings to past episodes and upcoming episodes that you can sign up for as well. So check back there if you want to grab the recordings from today or if you want to see the other sessions that we have coming up. Now, as I mentioned today, we're going to be talking with Johan-Till Broer. I'm sorry if I'm not pronouncing that exactly right.
No, it's right.
So Johan is Vice President of Product Development for MakerBot, and he oversees global product strategy development, go-to-market initiatives for MakerBot's 3D printing solutions. During his tenure at MakerBot, Johan has held senior positions within public relations and product marketing, and was then tapped to lead the product team. He was instrumental in the launch of the company's core products, including the MakerBot Replicator Plus, the Method and Method X 3D printers. Johan has over 10 years of experience launching technology solutions, including 3D printers, navigation devices, infotainment systems, wearables, and more. So welcome to the session, Johan.
Thank you. Yeah, thanks again for having me.
Yeah,
Absolutely.
thanks for being here.
Absolutely.
Yeah. So to get started, I was wondering, Johan, if you could share a little bit about your role at MakerBot.
Sure. So, as you mentioned, I oversee the product team. So essentially my team manages all of the products at MakerBot, starting with our 3D printers, going to materials and software. And really we basically tie together everybody, right?
Mm-hmm.
Like we manage the whole life cycle of the product from like the early concepting and road mapping to, proof of concept, development, launch, shipping, then, managing the product in the field and eventually end of lifing a product. So yeah, it's been very interesting. I've been at MakerBot for 5 years now. Starting in public relations and marketing before going into the product team. And it's been a very interesting journey, and we can talk a little bit more about it. I think anybody who has watched MakerBot from the outside probably will realize kind of how much the company has changed in terms of the product offering that we have today, in terms of the products or the customer focus that we have. That has also changed quite dramatically. Yeah, so that's a little bit of background.
That's awesome. Thank you. Before we get into the Method and Method X, can you tell us a little bit about the other key elements of the MakerBot product line, like the Replicator Plus, the Sketch Classroom Bundle, and the MakerBot Cloud Print?
Sure. So at MakerBot today, we have two main customer segments that we develop solutions for. So we have the education segment and we have the professional segment. Mm-hmm. Both of them are very different, right, in terms of the customers and what they actually need and the problems that we are trying to solve for them. Because at the end of the day, we're not just making a 3D printer, we're trying to help someone to get the job done, right? And in education, that means we're helping teachers to use 3D printing as a learning tool to really help teach STEM, but also help, teach skills that are very important in the 21st century. So, design thinking, problem solving, and doing that in a very hands-on way. On the professional side, we're really offering a tool for prototyping that can accelerate product development, and also for the creation of end-use parts. We have customers in manufacturing, manufacturing engineers that are printing jigs and fixtures. We have small entrepreneurs that are printing small batches of end-use parts, actually, like drones and other things. So that's kind of gives you a little bit of a background on the two different markets. So before we kind of talk about the method X and the method, to answer your question, we do have the Replicator Plus and the Sketch offering, and those two really serve the education market. And as I mentioned before, in the education market, it's really the printer itself is important, but what's even more important is how we empower teachers to use the 3D printer as a learning tool. And we have developed a whole ecosystem around the printer to do just that. So we have hundreds of lesson plans that teachers have access to, so that when they get the printer, they know kind of how to teach it. And even on Thingiverse, we have a whole community of teachers where you can search by the topic. Like, let's say you're an art teacher or a history teacher, you can find the right lesson plans that you need to teach, so you don't have to start from scratch and develop everything yourself. In addition to that, we also offer MakerBot certification. And that is something that I think is really cool and really good for educators when they get started, because we teach the teacher how to use the printer. We teach the teachers, so basically it's like a class, right, that you sign up for, and it's an interactive course that you can complete, and there are different modules, so you can learn how to operate the printer, you can learn how to design for 3D printing, you can learn how to create curriculum that you can then share with the community. And we have the same thing also for the students, so that they can go through that. And it's a very structured way of teaching the teacher and giving the students also a way to learn the technology and learn design thinking. And so I think that is really crucial for us to address that market. And then the third thing I would highlight here is that we also have MakerBot Cloud Print, as you mentioned. That is a new cloud platform that we launched this year. And what it does is it allows you to, in the education market, it allows the teacher to manage the 3D printers in the classroom with the submissions, because oftentimes the students, want to submit prints and the teacher wants to kind of review them. So we give them a mechanism to send out an email to all the students. They can upload the file, and then the teacher can review the files and send them to the printer. So it's a platform that allows you to manage print submissions and printers, to monitor the prints as they're going on, and to prepare files. And what I just described is obviously for the education market, but this platform also is very, very useful for the pro market, of course, and especially during these times where a lot of people are working from home. They may not be, right next to their printer. So with Cloud Print, they can remotely manage that. And let's say, you have like 5 engineers on your team. These engineers can remotely submit their prints to different printers, queue up the files, and then whoever is managing the printer can go through all of those different prints.
Right. That's awesome.
That is, and I agree. It's really all about the content. I'm glad that you guys provide the lessons and the training materials. It's so important, as opposed to just giving somebody a box and saying, here you go. It's
Right.
They're going to get a lot more value out of the solution that way. So before we get into the method and the method X, which we'll be focusing on today, let's go back to something that you kind of mentioned or alluded to in your opening remarks, Johan, where some years back, Ultimaker went through a period where some people sort of had a bad experience, especially with that Replicator 5th gen when the smart extruders were first introduced. There were some issues with that, and it kind of soured some people on the MakerBots a bit. And I wonder if you could just talk a little bit about what's changed in recent years, what maybe were some of the takeaways from that period, how have things changed now with respect to the way MakerBot does their products and their support compared to maybe a few years back.
Yeah, so this is something that I kind of alluded to in the beginning. I think that over the last couple of years, like even the 5 years that I have been at the company, I have witnessed a very, very much a transformation of the company in terms of how we approach product. Also, a stronger focus on the product, right? That's something that is important. I think we have become more of a product company that tries to, first of all, be closer to the customer, understand who is using it, who are we developing these solutions for, but then also in the product development process, really emphasize product testing a lot more, large scale testing. So we go through a process that's called application-based reliability testing. So that's basically like a large scale testing where we have like many printers. You know, it could be anywhere between 30 or up to 100 printers that for a very long time print parts that are representative of what a customer would be doing, right? And this process is like, it's very intense. It takes a long time in the process, and that has become a very crucial part of how we make sure that a product is ready before we ship it. And really the first product I would say that where this applied was the Replicator Plus, which was the improved version of the original 5th gen replicator, and which now is really very much a standard in the education market in terms of the ease of use and the reliability that it provides. So that printer in total went through 380,000 total hours of testing if you add up all the hours. So it was like a really massive amount. And the printer itself had a couple of improvements. It had a completely redesigned gantry, and it also had a new extruder, so the Smart Extruder Plus, that had many improvements to improve the life and the reliability of that extruder. And that was kind of, I would say, the turning point in terms of how we approach the development. Since then, we have progressed even more. I think we have become much more customer focused in terms of when we develop the products. We involve beta testers. We get like regular feedback from actual customers, not just the reliability testing that I just mentioned that happens, you know, obviously like in a lab. So it's a little bit more controlled, which for us has the benefit that we can get all the data right in real time and analyze it and work with the engineering team and make changes. But getting that real feedback from the customers that we work with, I think is the other really crucial piece. And then I would say also we have like over the last couple of years started working much more closely with Stratasys, and that's very I think evident in the method 3D printers, where you know, very early on in terms of the design, our team has collaborated with the engineering team at Stratasys to tap into, you know, the 30 years of experience in FDM printing that they have. And today, when you look at the design, you have with the methods platform really a something that bridges the gap between the desktop space and the industrial space. And even if you just look at the extruder design and compare that with some of the extruders from Stratasys, there are a lot of similarities that you can see. So it really, you know, I would say that the kind of rigor we put into testing the products, working with the customers, and then also collaborating with Stratasys, I think that combination really is something that is very powerful and you know, has changed the way we do things.
Okay. Yeah, thank you.
Thank you. Let's see. Can you tell us about the Method and the Method X and what makes these printers unique compared to the other desktop printers that are out there?
Sure. So that's probably one of my favorite topics to talk about. So, you know, when you look at like desktop 3D printers in general, including MakerBots, all of the other printers, basically they all use an architecture that dates back all the way to the RepRap project. So the architecture is very similar. You know, you have a heated build plate in terms of like how the frame is designed. Everything, you know, kind of has improved dramatically, no doubt about that. A lot of incremental improvements have been made. But when we look at the method printer, it's very different because we basically said, scratch all of that. We're going to start from scratch. You know, we're going to start with a blank slate. talk to Stratasys, understand what they're doing, and try to see how can we make a printer that basically is provides dimensional accuracy, repeatable results, but do that at a price point that's accessible for engineers, individual engineers that are going out there and wanting to buy maybe their first 3D printer for their organization. And so when you look at that printer, really it starts with, I would say the feature that stands out the most obviously is the heated chamber. All of the desktop 3D printers have a heated build plate, so you're controlling basically the temperature of the very first layer. But as you move up in the Z, you have no control over the temperature. And that is a problem when you are printing plastics, because plastics, they want to contract, and they need a certain temperature, and they need to cool down slowly, or otherwise they will crack, they will deform. And that is, like, I would say, more true for the engineering materials, and for the higher temp materials like ABS, polycarbonates. If you're printing PLA, your heated build plate is going to be fine. But if you get into the real engineering materials, you really need the heated chamber to make sure that the parts cool down gradually, they can relax, and you get a part that has dimensional accuracy. And there are many other features in the printer. I would say, like, we have a very stiff frame, so that avoids that as the printer is moving around, that you get too much kind of movement in the frame, which can affect also how accurate your part is. The extruder itself also is very different, has a very, very long thermal core, so we can heat up a lot more plastic at once, and that means that we can print much faster. And and also the filament, the way that we store the filament, I think it's another crucial thing that we do. We have dry sealed filament base, so I think the more you learn about high performance materials, especially like nylons, they do tend to absorb moisture, so you really need to make sure that you control the moisture uptake. Mm-hmm. These are just some of the examples of how these printers are different. And I think I want to touch again on the dimensional accuracy, because that's something that when you make a 3D printer for the engineering market, that is something that's very important. Because when you design parts of it as an engineer, most of the time you're dealing with some kind of a assembly, right? Like, you have different parts that need to fit together. So the part that you print needs to match the dimensions that you put into your CAD file. And I think with desktop printers, engineers have, some engineers have found ways around it. Like, they do multiple iterations, they try to change some dimensions and somehow get to a part. But that is a time-consuming process, right? So the idea of a 3D printer is that you speed up your development process. So you want to make sure that you print the part and it fits. And so that's why the heated chamber is so important, because we can guarantee dimensional accuracy of the printed part. And that is something that's very different from, let's say, layer height, which just means it just defines like how thick is the layer that you're printing. And so that can be something that is like it is beneficial in terms of aesthetic print quality. Let's say you're printing something at an angle. If you have a very high layer height, you get these little steps, right? That's something that's important, but it doesn't say anything about how well do the dimensions of the printed part match your original dimensions. That's something where the heated chamber really comes in as a benefit.
That's really awesome. Thank you for sharing all of that. Can you explain the difference between the Method and the Method X?
Sure. So both are built on the same platform. Both, use the same extruders. Everything is the same. The big difference is really the chamber temperature. So the Method goes up to 60 C, and the Method X goes all the way up to 110 C. So really that defines the materials that you can print with. So, the Method X prints more of the higher temp engineering materials. So if you want to print ABS, ASA, PC ABS, polycarbonates, those all print on the Method X. The Method can print more of the basic materials, PLA, PETG, You know, it can also print nylon carbon fiber, which I think is a big upgrade for that printer. But yeah, it really depends on what you're looking for in terms of the materials.
Thank you.
I have a question going back to what you were just talking about in terms of dimensional accuracy. And, you know, something that I think there's some confusion over in the industry is when people are shopping for 3D printers, a lot of the printer manufacturers like to talk about, you know, resolution, minimum layer heights, positioning precision, you know, how accurately can they position the print head? And they'll give terms of, you know, so many microns and things like that. But I thought MakerBot was a little unique in this regard, is that in that you guys seem to focus on dimensional accuracy of the final part, as opposed to focusing on, you know, aspects of the printer head movement or whatever else. You're looking at the end result, which I think is kind of like what you were describing. That's what ultimately matters to an engineer trying to fit parts together. So would you agree that MakerBot is a little bit different in how they talk about dimensional accuracy in relation to the method series?
Yeah, so we do see that as a core feature of the method, right? Is the dimensional accuracy of the printed part. And I think, you know, as you mentioned, the layer height it's sort of a little bit misleading because people think, oh yeah, you know, it's 100 microns. So, you know, my part is going to be within 100 microns of accuracy, which is not true. It's just really just how thick is your layer. It doesn't say anything like your part could be cracking, it could be warping, it could be completely off in terms of the dimensions, right? And not fit together at all. And so we actually do have like also a couple of different parts that we use, you know, to showcase to people like, look, you can print this on the method and print it on your desktop printer and see like how well these parts fit together, and you will see the difference, right? And so that is something that also comes from it's a way of thinking that actually comes from Stratasys, because they also on their more industrial 3D printers, on the F series, for example, they give the dimensional accuracy spec because they know at the end of the day that is what their customers care about the most. But in the desktop space, there's a lot of confusion around this, and people, I think people don't necessarily understand right away what the difference is between, you know, accuracy and like dimensional accuracy and like
right. There's so many terms thrown around. And I'm glad you brought up those sample prints. I actually have them here because we've done these, and I'll just share them real quick for those that are watching this on video. There's this cube test that you guys make available where there's two halves that are supposed to fit together. And we printed this with the exact same settings, same material, ABS, on the Method X, and then on another brand of printer. This is the other brand, and it just, no matter how you try to manipulate these blocks, you can't quite get them to fit together. And I did that same print on the Method X using, again, the same settings, same material. And as you can see, it fits perfectly together. So that was really impressive to me because it was a really clear demonstration. Here's another one that's circle test where you have, you know, grooves on one side and you know, fins on the other side, and they're supposed to fit together. This was done on another brand of 3D printer, and you just can't quite get them to fit together no matter what you do. Printed that same part again on the Method X, and not only does the part fit together smoothly, but you can rotate it smoothly, which shows that it's printing perfect circles, that it's not getting any kind of ovalness in there. So, you know, again, just really impressive demonstrations of using the exact same model, exact same slicing settings, two different results from two different printers.
And I think when you think about the professional use case, obviously, if you're prototyping, you want to be as fast as possible. Most of the time, I think product development teams, just even as my own team, right, they're under a lot of pressure to get things out as fast as possible because, you know, there's revenue attached to it, there's many implications to it. So I think a lot of companies look to 3D printing as a way to kind of accelerate that process and be faster than like outsourcing it, waiting for the part to come back. And so if your parts don't fit and you need to do it over again, you're losing days, you know, trying to figure that out. That's one part. But the other part is like end-use parts, right? There's so many companies, you know, we talk to big companies that adopt 3D printing for jigs and fixtures, where they have a system where they print a fixture for someone on the manufacturing line, and then they will have like a number, or they have some kind of system where that person, when the fixture breaks, right? Like at some point it breaks, they have to come back and say, can you print this again because it broke? And in that case, it's even worse, right? Like you need to make sure that you can exactly replicate that part, because otherwise it may break your manufacturing process if you can't replicate that part. And that's why it's so important that with the heated chamber, we take the temperature in the chamber so that when we reprint the part, it's printing exactly at the same temperature. Where when you have a heated build plate, depending on your environmental conditions, the temperature may change, So you may not get the same part back. And so that's the kind of reliability, I think, that overall 3D printing, that's a major thing to overcome, to make it a reliable tool in the professional environment that you can actually rely on, not just something that someone like is playing around with and doing some nice like concept with here and there, but like how do you integrate it into that kind of setting as a tool that you can rely on? And I think that's the kind of thing that we're doing with Method.
Very cool.
Very cool. You mentioned that the Method and the Method X offer dry sealed filament bays. Why is that important?
So, I kind of like hinted at that, but many of the 3D printing materials absorb moisture. So some support materials like PVA, for example, it's a water soluble support. So if you leave it out in the air and you have like high humidity or moisture in the air, then it will absorb that. And when it does that, it will really impact your print quality. It's not just the support materials, it's also very, I think, prevalent with nylons, because especially nylon 6, those materials tend to absorb moisture very fast. And then you get a lot of stringiness, you get like oozing in the print, and it creates lots of defects. So with the dry sealed filament base, we control that moisture and make sure that the filament stays dry. We not only do that in the way that we store the filament in the printer, but also when we ship the filament, it comes with desiccant, it's like in a sealed packaging, etc. Mm-hmm. So, personally, I have become even more aware of this as we have expanded the kind of materials that we add, how important the moisture management really is for these materials.
Yeah.
So on that topic of materials, let's talk a little bit more about the different kinds of materials people can work with if they opt to get a Method or Method X. Now, you mentioned a number of these before. Let's kind of step through them, and let's start with the MakerBot stuff. I know there's a lot of people out there that kind of have the impression that MakerBot printers, you have to use the MakerBot materials, which really isn't necessarily the case. And we'll talk a little bit about that. You can use third-party materials with these printers, right? You just need to use the experimental labs extruder. And so we'll come back and talk more about those third-party materials, but let's start with the MakerBot materials that are being offered. What are some of the options that you have with the Method and the Method X?
So yeah, we have a whole range of different materials. As I mentioned, we have the PLA, we have ABS, we have PETG, we have ASA, we have PCABS. We also have a flame retardant PCABS. We have from there, we kind of move on to the more advanced materials. We have nylon carbon fiber. We have a basic nylon carbon fiber, which is basically a 6-6 blend. And we recently also introduced a nylon 12 carbon fiber, which has some benefits because it's not as moisture sensitive mainly. Mm-hmm. And those are, I would say, those are like the core kind of materials that we offer. We try to kind of cover all of the major categories that we see are most relevant to our customers. When we bring these products out, or these materials to market, we do a lot of testing, again, for the dimensional accuracy. We do all the measurements. We do a lot of lifetime testing. And in addition to that, we also have the labs materials. Before I go there, though, I want to also highlight that we have, in addition to the model materials, we also have support materials. So we have, on the Method, we have PVA. So that material works very well, with the PLA or with PETG. And then for the higher temp materials for ABS, PCABS, we have SR30. And so we're actually the only printer in that price range that has SR30 soluble support. And it's a great material because it essentially is a modified version of ABS. So it bonds very, very well with that material. So what that means is that you will get a very, very nice surface finish. And the soluble support obviously is great if you're printing very complex parts, something that has internal cavities, things where you can't break away any kind of support. But again, also the other benefit is that the surface finish is just so much better than anything you would get from a breakaway support. And that material is also less moisture sensitive than, let's say, a PVA. So that makes it also more reliable in terms of how it prints. And yeah, in terms of the labs offering, as you mentioned, these are all our official materials. They also have the spools have RFID chips, so that's a great benefit, I think, because it helps you to track how much filament you consume. You can get warnings if you don't have enough filament left to complete your print before you start it, etc. So many benefits to that. But we know that the kind of people that buy these printers, oftentimes these are engineers that are passionate about 3D printing. They kind of want to change something in their organization. They want to they kind of work hard to change the mindset in their organization to think more 3D. And oftentimes, they face like an uphill battle to convince their superiors to kind of buy into it. And what is this toy? Can it really deliver? and so for that reason, we do want them to or enable them to print with more materials, and experiment and try out new things. And that's why we came out with the Labs extruder, which is an experimental extruder that basically unlocks your printer. You can side load the materials through the aux port. We have also a printable side mount that you can print out and then put on the side of the printer, and you can put the spool on there and feed it into the aux port, and then print pretty much any material you want. And the extruder design itself also, I think, is very interesting because we decided to make the nozzle tube assembly, which is at the bottom of the extruder. So it includes the nozzle, but also the PTFE tube inside, which kind of guides the filament through. We made that customer replaceable. So that's the part of the extruder that fails the most. So that if someone experiments with materials and for some reason they have an issue or it wears out, they can easily replace that and they don't have to buy a new extruder. So that kind of is something I think that really fits that mindset and allows people to experiment a little bit more. So that's the kind of one thing. But the other thing, part of this is also that we have a materials development program. So we work with some of the major filament suppliers, Polymaker, BASF, Lifoss, Jabil, and we work with them to qualify their materials for Method. So we have a process where these companies, they have the Method X, and they have a certain process they have to go through, like print a certain sequence of prints to qualify a material and tune it, give us the settings so we can publish the settings to the users. And so that way we can give users more confidence in printing the material because the material supplier already tuned this material and the user doesn't have to start from scratch, right? So that way we're able to very rapidly expand the number of materials that can print on the machine. And, in some instances, very significantly, I think, because Polymaker, for example, qualified 3 of their polycarbonate materials. And polycarbonate is even more difficult to print than ABS because it warps and contracts even more. And they had very good success on the Method X printing these polycarbonate materials. They were very impressed, and it's a great way for us to offer materials that you can't necessarily print on a desktop printer, or you can't print them very well.
Right. So quite a lot of material choice, and that's what I love about 3D printing. You make an investment in a 3D printer, and all these new materials keep coming to the market, and you keep getting these new possibilities, over time. And certainly there's so many materials that would benefit from the active heated chamber on the Method series. So many advanced engineering materials that are being introduced on the market that might be a little bit trickier in terms of build plate adhesion or warping tendencies, things like that, where having that even heating throughout would really be welcome. So that's great that you have
Yeah,
that.
I even like see it. I see like really our printer as a platform. You know, you can almost. I like to compare to smartphones where you have app developers. You know that like your smartphone is nothing without the apps, right? Like the people developing it. And really, when you look at the filament space, these companies are almost they are developers, but they're coming up with new and innovative materials. Like sometimes they take something that's used for injection molding and just make it available for 3D printing. Sometimes they come up with new formulations and new blends
Yeah.
that do something very new and interesting. So I see it as that we provide like the platform. We work with all these different material developers, where material companies to provide these materials to enable new use cases on the printer. The polycarbonate is one. The other great example is the SEPS 95A, which is a flexible material. So we didn't have a flexible material previously on the platform. Jabil has this really great material. It has many benefits. It's almost like a rubber, but it also is less moisture sensitive than, let's say, a TPU, which is where you have like a lot of issues with the moisture uptake. So this material doesn't have that issue. It prints really well, works with PVA. You can also print very complex, flexible parts. So we have been able to really expand what people can do with the machine.
Nice. Nice. Yeah. Now, you mentioned a lot of different material options there, but one of the ones you mentioned was nylon carbon fiber. And I wonder if we could talk about that for a moment, because these composite materials become really popular. And so the method has the Model 1C extruder, right, for composite materials that has a hardened nozzle, correct?
Correct. So this year so when I said method is a platform, basically, the other nice thing is that we continue to invest in different accessories that you can buy for the printer. So someone who bought a method or method X, last year, maybe they bought it for ABS. This year we introduced a composite extruder. They can just buy that extruder. Now they can print nylon carbon fiber, which is like a very significant change in terms of like what they are able to do. And so this extruder itself, it's optimized for composites. So we ran a lot of lifetime testing, and we saw, because the materials are very abrasive, they wear down the gears, they wear down the filament switch inside the extruder. So we added hardened components inside that printer. And the reason why these composites are so popular is because they offer much better mechanical properties than ABS or most of the standard polymers. So if you compare it to the nylon carbon fiber that we have, if you compare it to an ABS, has more than twice the strength, tensile strength, has like about 3 times, the modulus, so the stiffness is much, much higher, has like 100C higher heat resistance. So you can imagine the kind of things you can do with this material. It really expands the applications, and specifically in manufacturing. When you think about applications on the manufacturing floor, different fixtures or work holdings that hold like something in place, like in the CNC machine, for example, where your CNC head comes down and applies a lot of force. You need really a strong part, or like end effectors like grippers that have to hold something. Sometimes they have to be very strong. So these are the kind of applications where nylon carbon fiber provides huge benefits. And the one thing that I thought was also very interesting in this whole process is that the nylon carbon fiber works with SR30. So you can print very complex parts where, we also have breakaway support, which is great. And for nylon carbon fiber, it actually works pretty well because the material is very stiff. So the supports, when the material is more ductile, like an ABS, the breakaway doesn't work as well.
Right.
For a stiff material, it works well. But still, if you have something really complex, or if you want a really smooth finish, the SR30 really is a key advantage. And yeah, even like in the nylon carbon fiber or composite area, we're expanding pretty rapidly. Just earlier this year, we announced the nylon carbon fiber. As I mentioned, is a nylon 666. The main advantage there is it has very high heat resistance. Also has very, very high tensile strength. The downside is that it absorbs moisture much more quickly. So we also introduced a nylon 12 carbon fiber recently, and that material while it has a little bit less strength, a little bit less heat resistance, it doesn't absorb moisture as fast. So I would say that, or recommend to most users, unless they need, like, they have a super high heat application or they need that extra tensile strength, I would recommend the Nylon 12 carbon fiber, because it's much easier to work with and prints really, really nicely.
Got it.
That's awesome. What are the different kinds of extruders available for the Method and the Method X, and which materials are they intended for?
Yeah, so we have the one A extruder for it's basically more of the basic materials, your PLA, your tough, your PETG. Then we have the extruder for ABS, ASA, PC ABS. And then, as mentioned before, we have the composite extruder that we just introduced. And then in addition to that, we have the labs extruder. And one interesting thing also is that we really take, like, our strategy is really to make very quick improvements, as I mentioned, to this platform. So even very recently, we also upgraded the labs extruder to incorporate some of those changes that the composite extruder has. So it's called the Labs Gen 2 extruder. So basically, it's the next version of the Labs extruder, and that also has the hardened gears and the hardened filament switch. So now you can get longer lifetime when you're printing composite materials, which we will add more of those on the lab side with some of our partners.
Cool. Thank you.
So you mentioned that the Method X can print using this SR30 support material for the higher temperature materials like ABS and ASA, that kind of thing. What does somebody need to have if they wanted to take advantage of that capability? You need some extra gear, right?
Right. So there's a wash tank that we recommend that you can buy. It's essentially the same wash tank that Stratasys uses for their machines. That's the optimal, best solution, best use case. You can also, we have seen, like, people use a sous vide solution. We've also have some people in the office that do that. They just use some kind of a container in the sous vide, and it will do the job. But yeah, essentially you need that. So basically you need heat, you need agitation, and then you also need EcoWorks, which is a solution. It's little tablets that you put in the water, and they dissolve the support material. So I would say, for sure that is a little bit of an extra step that's necessary. But in turn, you get really the better surface finish and the more complex parts. If someone doesn't want to really invest upfront into something like that, as I mentioned, we have breakaway. So we have breakaway support also for ABS. But I would recommend to start with the breakaway and the nylon carbon fiber, because on that material, as I mentioned before, because it's so stiff, the breakaway actually works quite well. So that's I think a way for customers to get started, and then see if they from there want to upgrade and invest either in a sous vide or into a wash tank.
That's awesome. Does MakerBot plan to continue expanding the materials offered for the Method and Method X?
Yeah, so when we first launched Method, we had 3 materials, and today when you go to our website, we have 20. So we have a pretty rapid expansion, and yeah, we plan to continue to do that. We actually are seeing, like, a lot of interest from our partners in qualifying materials. And yeah, you can expect a lot more to come. There's some more this year that are coming, and there's more next year coming. A lot of very specialized engineering materials, higher temp materials. So yeah, there's a lot more to come.
That's great. How do you see companies and businesses using the Method and Method X printers?
Yeah, so I think, like, functional prototyping is one area that is obviously really big. People, especially people that design parts that have to be injection molded in ABS. They really want to 3D print the part in ABS to get to similar properties. And that's something that I didn't mention before. In addition to the dimensional accuracy that the heated chamber provides, it also provides you better layer adhesion. Because when you can imagine with the heated chamber, as you extrude, your filament, because we control the temperature, the previous layer stays hot longer. So as you extrude on top of that layer, both of the layers bond much better than when the previous layer cools down, right? So that's just how plastics work. So you get stronger parts. The other piece also is that we talked before about accuracy and how there's a lot of misleading information. I would say the same is true about filaments, because we print with an injection molding grade ABS. So it's very similar to the ABS that you use for injection molding. So that is very beneficial when you're doing functional prototyping. You're trying to kind of simulate the function of a part, right? But the ABS, for example, that's on desktop printers, it's not a real ABS. It's actually a modified ABS, because if you print ABS on a desktop printer, you somehow have to fight the warp, because this material really wants to warp. And the way they do that is they add certain modifiers into the filament so that it prints better. It still doesn't print perfectly. You still see issues with it. But what you're also doing when you add these modifiers is that you're compromising some of the properties of the filaments. So you're not really getting the real ABS. So the functional prototyping, I would say that's one of the really biggest kind of applications that we see. But beyond that, there are two other categories. One is jigs and fixtures, as I mentioned before, on the manufacturing floor. And another one is really small batch production of end-use parts. So, we have talked to customers that, for example, create a small number of, electronics devices that, measure something, right? Like, and so they need the housing for that, and they have very low volume. So going to injection molding makes no sense for them. So they need to print it. And in that case, the properties are even more important, because you want to make sure that in the sun you can't have like deformations, etc. So you need the heat resistance. You really need a true ABS. So those are the three areas. I think in manufacturing, like one customer that I always like to highlight, it's called All Access Robotics. So it's essentially it's a machine shop, but they also offer automation solutions for other machine shops, for factories. So essentially, you can come to them, and say, I want to automate this process in my factory. Like, let's say I want to automate a CNC machine, and they will provide you the full solution. So a robot arm with the fitting, end effector, the software programming, everything. So this is like an example where a company needs a lot of custom parts and very few of them, because essentially if you're trying to automate a certain task, your robot arm always needs a custom end effector, which is basically the part that goes onto the robot arm, depending on what it's trying to pick up. For example, if it picks up a certain part in the CNC machine and tries to put it somewhere else, they have very different requirements. Sometimes they have like a very thin metal part, so they need to make sure the end effector is like printed in a flexible material, so that when it picks up that thin part, it doesn't deform. So it really is very custom, and they have benefited greatly from using the Method X for that, because they have saved a lot of money compared to traditional manufacturing. They have designed parts even that are not possible to create with traditional methods, or where it was just a lot cheaper and faster to 3D print that part.
Yeah, the turnaround time is usually a big advantage of the 3D printing. So what about warranty and support options on the Method and Method X? What options are available?
So we have a standard warranty of 1 year. We have a great support team, that is based in Brooklyn at our headquarters. So the advantage of that is they're very close to the product team, engineering teams. So really pride ourselves in having that in-house support team. And, it's a 1-year warranty, and obviously you have any issues, you can call our support team. They usually get back to you pretty quick. But beyond that, we also know that in the professional market, as I mentioned before, it's really important to not slow down anything, right? So, and we know that with 3D printing, sometimes people run into issues. So the way that we want to help with that is we're offering some premium plans, support plans. They're called MakerCare. So we have MakerCare Gold and MakerCare Platinum. And the Gold plan is for 2 years. The Platinum plan is for 3 years. And they have a faster response time. They include, they cover more of the cost. So even like regular wear and tear is included. But on the Platinum plan, one feature that I really like is the hot swap feature that we have. So essentially, if you have a problem with your printer and our support team determines that you need to send in your printer, they will send or mail out a new printer before they even receive the old printer. So that can really, if it comes down to it and you have a significant issue, cut down the time it takes, right? Because in the usual kind of support scenario, you would mail back your printer, we have to receive it, we have to look at it, and a new one is mailed out, so you're losing a lot of time. So this is something I think that is a great feature for companies that are concerned about losing time in the process. And it, like I said, it goes over 3 years, so it's a pretty long time period.
So that hot swap replacement option is on the Platinum 3-year plan.
Correct.
Okay, that's a nice option to have.
Yeah. Yeah, I think, like I said, it gives you peace of mind that, and for companies that really depend on the printer and they can't have the printer down for like a week, 2 weeks, and not being able to do anything with it. So I think in that case, it's a great option.
Yeah, definitely. What lies ahead? How is MakerBot going to continue adding value to Method and Method X platforms?
So I think in terms of materials, obviously we will add more, we will enable more applications, but also on the extruder side, we have new things. One of the nice things about the method is also that it's very easy to swap out the extruders. Another thing is it's very easy to also calibrate the extruders. That's something I didn't touch on at all. The ease of use of the printer, how we kind of optimize the UX and made sure that that is very seamless and easy to do. So we continue to expand like the extruders that are available and just expand the core capabilities of the printer, and also offer additional accessories. I can't discuss all of the details of that yet, of course. But yeah, there's definitely, if you buy a method today, you can expect that there's going to be more value added next year. And the same is true on the software side. So as I mentioned in the beginning, the CloudPrint software solution just launched this year. And we have a roadmap for new features that we're going to add to that, both on the print preparation side, and on the print management side. So yeah, there's a lot more to come.
Excellent. And on top of all that, I think we have some promotions going on right now on the Method series printers, right? You want to tell us a little bit about that?
Yeah, so we have a very nice promotion, 30% off on the Method or the Method X, and also 30% off any additional materials that you add to that. And then we also have a special Black Friday deal where you, on top of that, get a free Gen 2 Labs extruder added to that offer. So that is valid until November 30th. So if you buy before November 30th, that's, I would say, an excellent package, getting that extruder for free. Because one nice tip also for people that are watching, if you buy the machine, if you use the Gen 2 Labs extruder, you can also use that extruder to print all of your MakerBot materials as well. So basically that becomes almost a super extruder. You can use it for the open materials. You can use it for the MakerBot materials. It's composite enabled, and it's very easy to maintain because you can swap the nozzle.
Very nice. So we have 30% off the Method series, Method X, carbon fiber editions, etc. Those prices, by the way, are on our site on shop3duniverse.com. The other two promotions that Johan mentioned, the 30% off any additional materials and the free Gen 2 Labs extruder, just email us orders@3duniverse.org. We can get a custom quote together for you for those if anyone listening is interested. So thanks for sharing those details. Those are really nice promotions. Well, this has been very informative. Thank you so much for joining us, Johan. I know I've learned a lot.
Yeah.
Thank you.
No, thank you very much for having me, and have a good holiday.
Yes, you too. And
you.
for those watching, again, thank you for joining us. And please check out our blog, 3duniverse.org. Click on the 3D Universe Untethered graphic in the upper left. That'll take you to the page with the recordings and other upcoming episodes. So I hope to see you again for future sessions. Thanks, everyone. Have a great day.
Thank you. Bye-bye.
Bye.
Bye.